right. Here we go. Today is Tuesday, December 1st, and we are picking up here solving some more logarithmic and exponential equations. And we look at this one. 3 to the 2x plus 3 to the x minus 2 equals 0. Can you combine this 3 to the 2x and that 3 to the x? It would be saying something like x to the 4th plus an x to the 2nd. No, you cannot combine those. So we're kind of in trouble. We can do a little bit of rewriting. You may not see this right away, but that's all right. Stay with me. Could you take this 3 to the 2x and could you rewrite it as 3 to the x squared? Is that valid? Yeah, right, because when you write powers to a power, you multiply the exponents, so I just kind of unmultiplied it, if you will. Plus this 3 to the x minus 2 equals 0. Now I'm going to do a u substitution. So I'm going to say let u equal 3 to the x. So look what happens when I make that substitution. This 3 to the x gets replaced with a u, and that's u squared, plus this 3 to the x, that's a u, minus 2 equals 0. Hey, what happened? Doesn't this look quadratic now? It sure does. We've changed this exponential into a nice simple quadratic. Can you factor that? Can you factor it, Matt? Can you factor it? U plus 2 and a u minus 1, which gives us then two solutions. U equals negative 2 or u equals 1. But we're not done because our original equation had x's in it. So we need to solve for x. So now you're going to kind of undo that substitution. U is negative 2. So we're going to go right back up here to u is 3 to the x. So this becomes 3 to the x equals negative 2. Or 3 to the x equals 1. Everybody with me? All right, think about this one. 3 times itself a certain number of times equals negative 2. Can that happen? Could you multiply 3 times by itself or by the square root or any power of 3 to get a negative number? No, that is the issue here is the negative part. That's not, you can't do that. So this piece is the empty set. That piece has no solution. This piece, 3 to something equals 1. 3 to the, well, 3 to the 1 is 3, right? Yeah. 3 to the 0? Yeah. X equals 0. All right, let's go back and check it. 3 to the 2 times 0. That's 3 to the 0, which is 1, plus 3 to the 0, another 1, 1 plus 1 minus 2. Does that equal 0? Yeah, we're good to go. X equals 0. All right. So, Ryan?
Why can't you do like x equals log base 3?
You can. And remember we talked yesterday, you can't have an argument that's negative in a logarithm.
Okay.
So if you miss it and you go to here, and even if you still miss it and you type it up in your, for fun, do it right now. Type this up in your calculator. What's log base 3 of negative 2? See what your calculator tells you. So if you still miss it,
Error.
yeah, but it tells you something else. Non-real answer. Okay, it's giving you an error. It's giving you an error, but it is going to tell you a non-real answer. Similar to if you take the square root of a negative number, it tells you non-real answer. Right? Does that make sense? Okay, so if you miss it here and you miss it there still, and you type it up into your calculator, it'll all play out for you. Does that make sense?
Yeah.
Okay, so look at this one. 36 to the x minus 6 to the x plus 1 equals negative 8. All right. You're going to have to do a u substitution here because we have different bases going on. And it's going to end up being some form of a quadratic. So you've got to get something that looks like it in this form. We've got quite a bit going on here that we're going to have to manipulate. This 36, could you write that as a power of 6?
Yeah.
6 squared. So we could say that this is 6 to the 2x. Everybody okay with that one?
Yeah.
Minus, now I'm going to change this up a bit. This 6 to the x plus 1. Could I say that that is 6 to the first times 6 to the x? Do you remember when you multiply things with exponents, the bases are the same, you keep the base and add the exponents? Everybody okay with this 6 to the 1 times 6 to the x is 6 to the x plus 1? Yes? I need you to nod. Yeah? Okay, perfect. Equals negative 8. Okay, now we're going to kind of separate it just like we did in the last one. This 6 to the 2x I could write as 6 to the x squared minus 6 times 6 to the x equals a negative 8. Now do you see something that looks like it might be quadratic? Got something squared, then that same term here. All right, so u, what do you want to make your u this time? Helena, what do you think? 6 to the x, right? 6 to the x. So when we substitute that out, that's going to be a u squared minus 6u equals a negative 8. Will, do you have an idea now what to do? Right? U squared minus 6u plus an 8 equals 0. Now what? Marilyn, what do you think now? Right, we'll factor it into a u minus 4 times a u minus 2. It's going to give us two solutions here. U equals 4 or a u equals 2. Are we done?
No.
What do we have to do, Bella?
You have to go back and substitute back in the exact u.
Yep. So this is going to be 4 equals 6 to the x. Or either one, 6 to the x equals 4, it doesn't matter. Uh-oh. 6 to the x equals 4. First off, is that possible?
No.
Sure it is. It's possible. If it's positive, it's possible. But it's not nice like the last one was nice, is it?
No.
Nope. So, what are you going to do? Flip to logs. X equals log base 6 of a 4. And the other one's going to be x equals log base 6 of 2. There's your two exact answers. Now type them in your calculator and get the decimal approximations, please. Do you have them?
0.773.
Uh-huh. And the other one?
0.386.
0.386. Yep. Exact answer and decimal approximation. Oh, look, this time there's 2 answers. Last time there was only 1. This time both of them worked. Okay, so far? All right, look at number 9. Got any ideas down there in number 9 to get us started? Bella?
Maybe to take that 49 to the x and break it down further so that it's